The rate is a change in concentration of the product or the reactant per unit of time. So as you can see, we have a concentration here, moles per liter per unit of time, which is our seconds. We're just going to expand it. It's going to look like this. We have two rates, average rate and the instantaneous rate. The average rate here is just the average, right? The difference between the final and the initial concentration, and the difference between the final and the initial of the time. Obviously, the difference between those is going to give us the average, which makes sense. Instantaneous rate, there's no formula. It's just the rate at any given point in time, which we're going to be looking at down here for an example a little bit later on. Whenever we want to find the method to measure the rate, we got to choose the method to be used by looking at the measurability of the reactant or the product. Okay, so as you can see, these different methods that we can use. Number 3, we can have a precipitate forming, okay, and you can also have a change in pH here for number 5. So which one are we going to be using? It depends on the question. So if the question shows that the gas is being produced on the product side, okay, so obviously we can't use color change because that doesn't make sense. If we use a spectrophotometer to measure the absorbance of light, that's kind of useless to us. Same thing for precipitate formation. Nothing's being precipitated, collecting on the bottom of the beaker, right? It's just gas being released into the air. So obviously we're going to be using change in pressure, because if there's an increase of moles of the gas, is going to increase the pressure, which is going to increase the reaction to proceed. So we're obviously going to be using something like 2 instead of like 4 or 5. Again, it depends on the nature of the question. This question over here, we have this many moles per second of the CO2 that is being formed. So I'm just writing it here. This happens in 1 second. However, the question is asking how much in 5 minutes. Well, 5 minutes is the same as 300 seconds. So I just cancel out my seconds over here. So then by the end, I just multiply this and this together. I end up getting 0.165 moles of CO2. Next, I have down here for answering for BR2, whenever you have a compound or another element in the same chemical equation, just divide by denominator of the coefficient. So of course here, this is our CO2. CO2 here only has 1 for a coefficient, and BR2 only has 1 as well. Okay, I'm just going to put a 1 here as well because there's always an invisible 1 on the bottom. And then from here, I'm just going to cross multiply. So then I'm just going to isolate from a BR2. It turns out to be in that 300 second timeline, it's also the same, 0.165 moles of BR2. Next question over here, we at the 2 minute mark, we have this much. We're trying to find out what it is at 1.5. So 1.5, this is a 0.5 difference, right, from 1.5 to 2 minutes. What changed? Well, we had 0.045 moles per liter per second, but we don't care about what happened in a second. We care about how much it got consumed within this 0.5 minutes or 30 seconds. I'm just going to be 30 seconds over here. These seconds cancels out. I end up getting this concentration. So the consumption of the reactant means that it decreased, which means this here used to be larger, okay? So it used to be larger, so I'm going to be putting it over here. And then it decreased, right, because it got consumed, so it decreased by this much, 1.35 moles per liter. And then at the 2 minute mark, right after that, it became this, 4 times 10 to the negative 2. I just isolate from my reactant. That is the answer. Try this question yourself, pause the video, and I'll give you the answers